as the sun ejects a colossal solar flare into space, racing towards Earth. One can't help but wonder, what would happen if a solar event as monumental as the Carrington Event of 1859 occurred in today's technologically dependent world? With an increasing frequency of solar flares, Sunspot AR3664 has captured the global scientific community's attention. This gargantuan sunspot, stretching almost 200,000 kilometers across, is more than 15 times the width of Earth. Its visibility with just basic eclipse glasses has turned it into a stellar celebrity, sparking widespread interest in solar physics and space weather through educational outreach programs. This activity serves as a perfect example of how sunspots, which are cooler areas on the sun's surface caused by intense magnetic fields that inhibit convection, play a crucial role in influencing solar phenomena. These magnetic fields can become twisted, leading to sudden and powerful releases of energy known as solar flares. AR3664 has been particularly active, producing multiple M-class and even X-class flares. These intense bursts of electromagnetic radiation travel across the solar system and have immediate effects on Earth, manifesting as radiostatic spikes or disruptions in communication and navigation systems. Additionally, this sunspot has been linked to several coronal mass ejections, CMEs, large bubbles of gas and magnetic fields ejected from the sun's corona. When these CMEs collide with Earth's magnetic field, they can trigger geomagnetic storms capable of disrupting power grids and satellite operations. The heightened activity of Sunspot AR3664 brings to mind the Carrington Event of 1859, the most powerful geomagnetic storm on record, which had profound effects on the telegraph systems of the time. The recent behaviors of this sunspot raised the alarm about our star's potential to similarly disrupt modern technology, underscoring the critical importance of monitoring such solar features. Scientists use advanced tools like NASA's Solar Dynamics Observatory and various ground-based solar telescopes to keep a vigilant eye on this sunspot, studying its growth, movement, and magnetic properties. Understanding these dynamics is key to improving prediction of solar flares and CMEs, which in turn helps protect our critical infrastructure. Around the globe, observatories and science centers are using this rare sunspot event to educate public about the dynamic nature of the sun and its effect on Earth. Even without telescopes, people can witness this giant sunspot's rotation with the sun and observe its changes over days through projected images on sidewalks or screens. As we near the peak of the sun's 11-year activity cycle, the insights gained from monitoring Sunspot AR3664 are proving invaluable. In 1859, astronomer Richard Carrington observed a massive solar flare that caused a geomagnetic storm to hit Earth in less than 18 hours. Telegraph systems across Europe and North America were overwhelmed, with operators reporting sparks that were sometimes severe enough to start fires. Today, AR3664 is showing signs of producing similarly intense flares and CMEs, which could potentially lead to even more severe technological disruptions given our increased reliance on electronic systems and satellites. During the Carrington Event, auroras typically seen only near the poles were visible as far south as Cuba and as far north as Queensland, Australia. These vivid displays are a stark reminder of the powerful geomagnetic forces at play. With AR3664's recent activity, scientists and researchers have heightened their monitoring efforts, recognizing that such displays signal vast movements in Earth's geomagnetic field, which could herald broader electronic disturbances. The historical and scientific significance of the Carrington Event continues to resonate today, serving as a benchmark for understanding what we might expect from current solar activity. Discussions about AR3664 in academic and public spheres often touch on the potential for internet apocalypses or widespread blackouts, reflecting widespread concern over the vulnerability of our finely tuned, technologically dependent infrastructure to severe solar storms. Imagine a modern-day Carrington event. The consequences would extend far beyond mere auroral beauty, potentially crippling the global economy and disrupting daily life. This isn't just theoretical, as Sunspot AR3664 continues to mimic the 1859 event. The scale and intensity of a Carrington-like event today could surpass anything previously experienced due to our greater technological dependencies. During the original Carrington event, telegraph systems represented the pinnacle of electrical technology. Today, our world is interwoven with GPS satellites, power grids, and fiber optic cables. A severe solar storm striking today could lead to widespread outages. Satellite communications could be disrupted, GPS navigation could falter, and power grids that underpin modern civilization might fail regionally or even globally. The economic impacts, as outlined by studies like those from the National Academy of Sciences, could be staggering, with potential costs running into trillions of dollars and recovery times spanning years. Despite these dire predictions, advancements in technology since the 19th century have equipped us better to handle such challenges. Researchers now employ sophisticated models to predict solar activity and its impacts. Agencies like NASA and NOAA operate fleets of observation satellites providing real-time data crucial for early warning systems. Internationally, policies and protocols are being developed to respond to severe space weather events, with simulations conducted to test the resilience of national and global infrastructure. These efforts are essential in building a response framework that could help minimize the chaos of a Carrington-level event. As we continue to study and observe Sunspot AR3664, we are reminded of the formidable power of our star and the importance of resilience and innovation in safeguarding our interconnected world. Through continued vigilance and scientific inquiry, we aim to ensure that even if history repeats itself, we are far better prepared to handle its challenges than ever before. Thank you for joining us today as we explored the dynamic and potentially disruptive world of Sunspot AR3664. By understanding these powerful solar phenomena, we can better prepare for their impacts and safeguard our technology-driven society. Keep watching the skies and stay curious about the wonders of our solar system.